I'm Jens. I work for UKRI STFC Scientific Computing with sort of some of my time in the DAFNI team, the Data Analytics Facility for National Infrastructure. My role, my area of expertise is something like connecting infrastructures together between countries so we can do big science stuff. And in this case, in CReDo, my role is the data security architect for DAFNI, so that we can provide a secure repository where people can share their data and then derive information from that. The slides that you will see today, we will make available as a PDF or something. So don't worry about writing things down or noting URLs and stuff like that. We will make the slides available. It is possible that there are a few dangling sentences or things I have missed as I was preparing the slides. The slides obviously are joint work with the rest of the CReDo collaboration. So many of the slides will be from Connected Places Catapult. So in general, if you see things like slides with beautiful animations that work beautifully, then they will be from CPC. And if you see slides that are hastily put together and with no animations at all, then they're probably my slides. So let's see who is CReDo. So with the core team of CReDo, we obviously have asset owners in there. It's people who actually have things in a particular region of the UK where they want to study how the assets will be impacted by things like flooding or extreme heat, and how the impacted assets might affect other assets, both in their own infrastructure and in other people's infrastructure. As I mentioned, Connected Places Catapult, who have done all the pretty slides, are leading the project. We also have CMCL Innovations, who is a software team specializing in digital twins and stuff. And we have from STFC both the Hartree Center and the DAFNI infrastructure. So let's look at first what CReDo is and why we want to do the CReDo stuff. So we want to look at interdependencies between infrastructures. If you think of things like Storm Arwen, where you lost power in a region for a while, and how that impacted the rest of the infrastructure, people had to go to pubs to get a bit of power from whatever, from generators or huddle around candle lights and stuff. You want to look at a region and say, what are the kind of impacts, particularly from weather, given the climate emergency and the increasing flooding and extreme weather that we see in across the country? What are the impacts that might derive from that? And can we actually do some work beforehand, before they happen, to try and mitigate those failures, or at least predict when they might happen? So CReDo is a climate change adaptation digital twin. The aim is to look at a particular region, look at the different infrastructures in that region, how they interconnect with each other, and how they're affected by things like flooding or other climate factors. And initially, as you will see, we started looking at flooding. So if you think of a particular infrastructure, you have the floods that affect some of the electricity supply in that region. That failure of those components can cascade out of the flooded area and affect other bits of the infrastructure, and even affect other parts of infrastructure, like a telecommunications infrastructure, where if you lose power, then you also lose telecommunications. So understanding these cascade risks across infrastructures is what we're trying to do. Because if it happens, you may want to coordinate between the infrastructure providers to try and recover services as quickly as possible. And in a digital twin, before it happens, you want to study what are the effects that you might not even know about as an infrastructure operator, because those effects arise from somebody else's infrastructure. So if you were BT, for example, operating telecommunications infrastructure in a particular region, you do not know beforehand about the risks from the power infrastructure in that region, that you might lose power to your telecommunication systems because you can't see those assets. So that's where we want to come in CReDo and look at how these things connect to each other and how failure and degradation of infrastructure can cascade across to other people's things, other people's assets. And potentially you could expand that even further, like looking at road networks and stuff where you need to get in to an area to fix things, but the area is flooded and you can't get in quickly enough, or there's a storm and you might get some other effects that need to be taken into account. So here's a statement of the CReDo mission, which is essentially what I've just said. So I'll just skip through that and let you read that later on the PDF. In the timeline, I have to look this up because I can't remember time things very well. But we went through a phase 1 where we did the initial study, looking mostly at flooding. And at the time, we had very, very simple failure models. We just said, if an asset is flooded, it's completely failed. And if an asset is not flooded, then it's completely working, which is obviously a bit simplistic. Then in phase 2, we started looking at more sophisticated failure models with Bayesian networks and stuff. And now in what we call CReDo Plus, we're looking at also taking extreme heat into account, as you will see in a moment. CReDo Plus generally is the sort of program that we have for supporting the study of network effects in climate change. But there's a particular branch working with Ofwat, with the Anglian Water, and an Ofgem branch as well, which is coming to an end tomorrow, where we're also looking at some particular expanding these failure models to more sophisticated models, as you'll see in a moment. So for the Ofgem part in particular, we are looking at these more sophisticated failure models. How can we do better than saying a substation is failed or not failed? Can we look at degradation? Can we look at components within a substation? Can we start putting these models together and deploy them into the digital twin to get more sophisticated failure scenarios that are more closely aligned with what we see in real life? So the challenge here is that some of that knowledge is in people's heads, and we need to get that out of their heads and into the digital twin. But before we get into that, let's look at what it actually looks like on DAFNI. Because if you log into DAFNI, you will probably not see much of CReDo as sort of a normal part of the normal DAFNI infrastructure. And that is because we've set up a secure enclosure within DAFNI. So all the red bits with a sort of set of firewalls around the computational infrastructure that we've set up for CReDo is isolated from the rest of the normal DAFNI infrastructure. So within the DAFNI cluster, you have all of the normal DAFNI stuff that you know and love, and then there's a firewalled off bit that you can't actually access unless you are in CReDo, where people come in with a DMZ access, a slightly unfortunate networking term, which just basically means that there's a set of steps you need to take to log in. There's a multi-factor authentication login for the project infrastructure experts who log in and try and build visualization models. And they're then accessed by experts from the asset owners through the visualization proxy that you see on the right-hand side, which is running on the SCD cloud. And all of that is running inside one of our own data centers. So it's all hosted within STFC's infrastructure, which is part of the trust of the platform, that as an asset owner, you are not handing over your data to another asset owner. You're handing it to a trusted third party, to STFC, to DAFNI in this case. And then you trust that that data is then sufficiently well protected that it's not exposed to other asset owners who they would not inadvertently see where your assets are. So that's very much part of the package of getting to the data sharing agreement that we've set up. That as an asset owner, you can share your data with us because you can trust us, and then your data is protected from other asset owners, even within the same industry, like from one water company and the other water company. So that is a little bit of a bespoke thing. If you're used to normal DAFNI, you will probably have tried building models, you will have tried building workflows, you will have had visualizations that you can explore, and you will have looked up data in the NID to try and find the National Infrastructure Database, to try and find data sets that are useful to your work. And pretty much the same thing happens inside of CReDo, where we build models. It's a little bit more difficult because there's not the same kind of support. Workflows as such do not exist. But again, you can explore visualizations, which is what the asset owners do. And there's a data exploration as well, where we've had, for example, economists come in previous phases of the project, and they've explored the data sets to try and assign financial tags to individual assets to see where is the most cost-effective part of your mitigation strategy. So there's sort of two different lumps of DAFNI usage of the DAFNI platform. However, there is some parts of CReDo are available on the normal DAFNI platform that you know and love. So both in the sense that we've used existing HyPIMS models from the DAFNI platform to build the flood models for the region that we're studying, but also that there's synthetic data in there that is designed to not have any sensitive stuff in it, but to mimic some of the interesting features that we see in real life. So, for example, some of the cascade effects that we have discovered in the actual infrastructure will be designed into the synthetic data so that we can demonstrate how CReDo works using just the synthetic data, and then that synthetic data can support publications as well. So some of those bits are still fairly restricted, a little more restricted than perhaps they should be, but that's all part of the work that we're doing on making them more widely accessible. So with that, let's now move on to the asset modeling, which I will talk about a little bit more in depth for reasons that you will I will get into later. And as an example, because most of the work has been done in electricity networks, I will talk about electricity as the sort of the specifics for this. So basically, you want to design a failure model for an asset, which could be a substation or some such. It could be a transmission lines, it could be something or other. But where previously it was just failed or not failed based on whether it was flooded or not, we can now get into the more detailed explanation of how things can fail, not just as a thing, but also with components that can fail. So you could have, in extreme hot weather, for example, you could have components of a substation that fail or degrade. You might lose communications with it. You might lose a cable termination that degrades. You might have cables sagging in heat outside that then touch branches in the woods and catch fire or something. So there are all these factors that you can sort of design into your failure model for a particular substation. So somebody needs to design that in what we call structural elicitation, where you say, what are the factors that can affect any substation, and what are the factors that can affect a given substation, given that it's somewhere on the map. So for that, you want to start looking at the substations or any other parts of your electricity distribution networks, and you want to look at the kind of failures that initially will affect that, and you design that into the failure model. Then you want to look at how they connect to other things. So whether they're components that are part of your substation or whether they're components that are that affect it from outside. So you can have the cascade effects, for example, within the electricity networks. And then you look at the mitigation thing that you can put into a particular substation as well. Could you back up the communications with it? Could you reconfigure your networks to mitigate any risks that arise from the failure of a given substation? And you can repeat that exercise with all of your other assets as well. So eventually you can build quite a sophisticated model for the same region that will fit into a more sophisticated simulation that will do both flooding and extreme heat in this case, as well as in the future, maybe storms or other factors that you haven't thought of. So this model is now more sophisticated. We want to get information, as I said, out of people's heads. So you want to say, what happens to a substation given that it's sitting in extreme heat for several days in a row? What it's not something that we can actually simulate because we can't take a substation and put it into a heated environment. So we have to talk to people who know this sort of stuff. And those people will generally be within the distribution operators of the distribution networks. So they will know about all these things and they will be able to assign probabilities to some of these failures. What are the probabilities that you get failure or degradation given certain parameters, and how can those parameters interplay with each other to affect each other? If you get extreme heat, it can affect several components at the same time, and you want to try to design that into your failure models. So you look at your substation, sort of designing the failure in there, and then you look at what is the likelihood now of a supply interruption, where in the very early phases, we just said, if it's flooded, it's failed. Now you're looking at a more sophisticated design of that may or may not lead to a failure of the substation, which then in turn cascades across to other infrastructure, so the telecommunications operators that we saw before, and then you can assess with an overview of all the networks in the region, what are the impacts from that particular failure of that particular substation that we looked at. So overall, that gives us a much more sophisticated failure model that we can run as part of the digital twin. This is all part of increasing the flexibility, because you could start with your failure model and have it like very rough model of a substation. And as time goes on, you can evolve those things to be more sophisticated. There might be different types of substations. There might be substations that are sort of like different sizes or have different components inside. Some of those components will have different ages and different supply chains. Some of that knowledge will be in people's heads that you need to try and get out and turn into a mathematical model, which would be done by people who know about risks, modeling risks for insurance, for example. So you get all these things like Ribble distributions and the bathtub curve and things that are known to be failure models for other components that you could tie into a failure model that in turn will get the percentages, the parameters of those probability distributions assigned from the failures that are estimated by the experts in the field. So overall, you can work towards a more sophisticated failure model that will give you a good view of what that substation could look like in a digital twin. So to get this knowledge out of experts' heads, we normally need to give them, we can't sit them down with a sheet of paper to say, write it down, everything you know, because they don't know what we need to know. So we need to try and get that information out of people's heads in a way that is as user-friendly as possible. And moreover, that information has to be done probably, or has to be provided by more than one person. Because the engineers who go out in the field, they may be experts in particular bits of the substation, and they may have done repairs on different parts of the substation. And they may all have some different knowledge. They can all contribute to that failure model. So the point is to get people to contribute all of that together into this increasingly sophisticated design of a failure model for the digital twin. which you then need to deploy into the digital twin, because there will be lots of substations out there, and they're all in different locations, and they all have different environmental parameters. They don't all flood at the same time. They don't all have the same forests around it that can impact them. They like if there's a forest fire or some such. So the parameters, once they have been identified, then they will vary from one substation to the other substation. But some of the probability and the processing of those parameters will be the same for every substation. And that's the kind of thing we're trying to get out to. So we scale by having a failure model for a substation, which is then placed out in the world where they are actually placed in the real world. And you can then go back to your failure model and say, actually, there's a thing that we forgot to model, and we should actually tie that into that thing, because now we can do so expand, as we expanded before from flooding to extreme heat. We can now expand also to I don't know, other things, stormy weather or something, in a future version of the failure model. So here's what it looks like. When you log in, you have a dashboard which shows you some models with very anonymized names at this stage in my screenshot. So there's activity, you can see what models are there. You can review models as well, because you might be an expert in something and you review other people's models. You can see the models you have designed and you can share them with others. And we will then want to ask experts when they compose a new failure model for a particular thing. So what are the factors that might affect it, and how might those factors affect the thing by working together? So the failure of a component, because it has aged and because of the temperature, might all play together to increase the likelihood of a failure or degradation of a particular component, which then will have an impact on the asset overall. So that's the kind of thing that we want to try and put together in what we call structural elicitation. And then the next step, where you have another person saying, what are the probabilistic elicitations? So that's where you go into those parameters and you tweak them to say, well, the actual percentages of and the parameters of the probability distributions will be based on, again, knowledge of people's real life experiences with particular assets, and extracted in as useful a way as we can possibly get. Like, what are the percentage likelihood of a failure or degradation given certain parameters? So try and make it as easy as possible to get knowledge out of people's heads. In the real thing, there's a map which I have whacked out on this thing, but there will be a map of where the asset is. So the reason I go into some detail with this is that we want to pick up this elicitation tool and bring it into the DAFNI BSRW program. BSRW is the Building a Secure and Resilient World, which is, I'll say a bit more about it towards the end of the talk, where we want to look at how assets can fail more generally, not specifically for power networks, but for anything that can fail. If you have a car and you think of doing a failure model before you set out on a longer road trip, you might check the tire pressure, you might check the oil in the oil level, you might check whether you have enough petrol or whether you have enough charge if you have an electric, and all kinds of things. So that's the kind of thing, the failure modeling that you do in your head, maybe based on experience, that you know that how the car can fail. And maybe if it's in the winter and it's very cold, then certain kinds of failures are more likely. If it's in the summer and it's very hot, then other kinds of failures may be more likely in a car. So that's the kind of thing that we want to do in a generic way as part of the BSRW program. So we can make that tool available to people who do digital twin models in DAFNI. And at the same time, we can feed that back into CReDo as well. So if there's any more stuff that were the next phases of CReDo, we can feed that in as well, and CReDo can build even more sophisticated failure models. So I will just run quickly through some of the digital twin stuff as well with some screenshots. I will go through this fairly quickly because just to give you a view of what it looks like. Because obviously, once we've built the failure models, it's not much use unless it's actually deployed inside of the digital twin. And the digital twin is where, as an asset owner, you come back into the system and you say, can you show me a view of this region where I can see my own assets in that region and how they might fail, and what sort of failures could cascade through from other operators' infrastructure? Even if you can't see the other operators' assets, you can see the increased likelihood of failure arising from those cascade effects across the infrastructures. So that's where at some of these points for the electricity networks, you have gone out and deployed those substation failure models that you have just developed in the previous phase, because you want them to now actually do some work in the simulation of the digital twin. So that's where we need integration with other data sources, like the climate data models, for example. So we have used UKCP18 from the Centre for Environmental Data Analysis. So very conveniently, it is in the very same data center. So so we just have to knock on the rack next door in the data center and say, can we have the data, please? This is actually some of the things we're looking at improving in DAFNI. How can we make that integration better? And I'll also be saying a few words about this later as well. But within the CReDo platform, we have this pre-processing of data. Given that we're just looking at a relatively small region at this stage, there's not too much work to do. But as we expand out to larger regions and other parts of the country with other asset owners, with other water companies, other electricity infrastructure operators, then obviously we'll need more data sets. We'll need more geographic data. We'll need more climate and weather data for that region, as well as other topographical aspects like the water levels and the precipitation and other things we need for our models. So the point is that we bring all of this together on the CReDo platform. And by the time you're an asset owner and you log in, you just see the failure models that you have deployed, and you can maybe specify individual things for each of those asset models that we would not necessarily know as the CReDo operators. So for example, if the age of a component of a substation is a factor for the failure of the substation, then obviously you'll need to provide that at some point, because otherwise we wouldn't know and we wouldn't be able to do the realistic simulations. However, in future work of CReDo, we can look into tying that into it as well by, with permission, integrating that into the asset owners' databases of their infrastructure. So if as an asset owner, you know that an asset has a particular set of parameters, then you can make that data available to us. And then once that is deployed in the digital twin, then you can click on that asset and you can explore its failure models. So hopefully by the time as an asset owner you sit down and look at this, it all becomes much more user-friendly and still gives you a realistic view of what the parameters are for that particular substation and how you can mitigate any failures that could cascade across to it. So all of it needs to come together in a platform. I mentioned the DAFNI platform as a sort of trusted third party where asset owners could go with their sensitive data. But more than that, it also is in a data center where we already have the climate data available that we need and other data sets that we need to bring into this. So to be sure, there will be data from outside sources as well, like maps and geographic data that we take from outside sources. But the point is that within the data center, we can bring all of that together to do the digital twin modeling on the DAFNI infrastructure. So all of that comes together in these different data structures. Currently, some of those data sets are fairly simplistic, but increasingly we will be working with specific formats used within the industry. So it's not just like a CSV format, but it might be specific things that come out of energy systems, or as well as those from the climate infrastructures. And all of that comes together to try and share data across the infrastructure for the different asset operators, which then, as I mentioned before, we can try and extend with other things like transport and other stuff. So I rattled through the digital twin stuff fairly quickly just to give you a flavor of what's going on in the digital twin. And that's obviously specific to CReDo. We also want to look at the next steps. And particularly what happens with CReDo and DAFNI, because we're now operating this infrastructure and it's a lump within that red box of firewalls that you cannot really access if you're a normal DAFNI user. So how can we try and put this stuff together in a more comprehensive package for failure models in digital twins more generally? And some of that can happen within the BSRW framework. Some of it happens already within DAFNI in other NERC-funded projects. DNV, which is one of the participants in OFWAT, will already have done, by which I mean the OFWAT-funded part of the CReDo infrastructure, have already done stuff on Jasmine, and they have done stuff on DAFNI, and they're doing some of the sort of like insurance kind of modeling. So what are the actual failure types that you might see, and what are the kind of impacts that arise out of that? So already there are reasons to connect the infrastructures with DAFNI and Jasmine. So they give you different kinds of services, but they complement each other. So Jasmine gives you, for example, HPC infrastructure where you can log in and you could run stuff with Slurm. DAFNI gives you the user-friendly interface. When you have the asset modeler, you want to sit them in front of the user-friendly interface, whereas the expert who is doing the climate simulations could perhaps run that on Jasmine and feed the stuff over to the DAFNI model. And so we make use of the capabilities of Jasmine, which is bigger than DAFNI, but we make use of the user-friendliness of the DAFNI interface to give asset modelers a chance to actually explore their things that in a way that is suitable to their expertise. So they just need to they don't need to learn an operating system or command line. They can just explore that using the visualization that we've provided. And connecting it through to the CEDA archive is also useful because there are several data sets in there that we will want to make use of in the future. So this is something that we are looking at the moment, not as part of CReDo, but as part of the DAFNI Jasmine collaboration. Another part we have looked at as a part of CReDo is how asset owners could manage their own data sets. So if you remember back to the DAFNI infrastructure, we have a separate data host for each of the asset owners. And the idea there is that CMCL have built an API into each of the asset owner hosts so that in principle, they can just communicate with each other over those asset management APIs. So they provide their own visualizations of their asset infrastructure, but they can communicate cascade failures to each other. So this means that eventually we could work towards a model where asset owners run their own data host, either on their own infrastructure or in their own cloud, and we connect through to that. So the digital twin is driven by the DAFNI, so the climate models driven by DAFNI, and we then communicate the flooding and the extreme heat out to the asset owners, and they negotiate the impact between themselves, the cascades across the different infrastructures. So that's another model. It means that you cannot feed things back into the digital twin modeling, because if you lose power to a pumping station and the pumping station then cannot pump water out of a particular area or something, then maybe the flooding could get worse and you can't communicate that back. You don't get that feedback loop from the asset failures. But that may be something we can live with. In handling confidential data, we, as I mentioned, with the DAFNI platform, we're the trusted third party, the thing that everybody can trust to provide their data sets to. And the one question is whether we should expand that. We know that Jasmine has a use case for that as well, something like a trusted research environment, but not using healthcare data, but being able to process sensitive data anyway. So CReDo obviously is set up as a specific infrastructure with very specific parameters and things, and is run mostly separately from the rest of the DAFNI platform. The question is whether we will continue to do that, or whether we can do any better by providing different levels of assurance within the existing DAFNI platform. So, so that's another question, or whether we can use some of the TRE stuff that's been happening recently to also improve the levels of assurance that we can provide to data owners with sensitive data. Now, my background is in mathematics, so I have to sort of think as a researcher as well. Could we actually hide the sensitive data by doing something kind of like homomorphic encryption, except different? So with the cascade effects, you just want to look at the graphs. With the locations, you could hide them by encrypting them in different ways. So a given location could have a billion different names that are all nonsensical. But the digital twin would know what that name is, and being able to communicate that name out to the asset owner to say, this location will be flooded. And the asset owner only will be able to decrypt that message and actually note where that asset is actually located, because they would know that. So you could do more sophisticated cryptographic techniques to hide some of the information, although it would be specific in this case to geographic geospatial data and to the cascade effects that are modeled using a graph. So I want to just very briefly, as I wrap up, return to the Building a Secure and Resilient World program, which is a theme from UKRI that you can go and read up on. How do we strengthen resilience in the infrastructure and enhance national security and all those good things by looking at energy supply and other things. So the CReDo thing is funded via Ofgem and Ofwat in this case. But more generally, UKRI has a program for studying these kind of things, and DAFNI is able to provide funding through some of that program. I've taken the liberty of abbreviating it CERIA, but it's at the Center of Excellence for Resilient Infrastructure Analysis, which you can also go and look up on the DAFNI website and see all the good stuff. And obviously, with the digital elicitation tool that I mentioned, there are things that we will try and improve within the BSRW program in DAFNI. And there's some of the existing work that you can read up on this webpage, where you can see some of the other work that others have done that can also strengthen the capabilities of failure models that we derive using the elicitation tool. So we can build an even better elicitation tool that in turn we can feed back into CReDo in any future work in CReDo. So this is something that we very much want to do, and we hope to demonstrate this at the DAFNI conference in September that I hope you've all signed up for. So there's a lot of cross-pollination happening, both within the infrastructures with Jasmine and DAFNI and the CEDA archive, as well as on the user level, where you look at the BSRW projects and what we do in CReDo, and it all fits under the wider framework on building a trusted environment to explore digital twins for a secure and resilient world. And with that, thank you very much.
Thank you, Jens. Has anybody got any questions for Jens? I actually can't see them, so I think Lindsay's going to
Yep, we don't have any in at the moment, so free to leave it a couple of minutes.
Oh, thank you.
Stunned them into silence. Well, if you have any questions, Obviously, you're welcome to contact CReDo. So this address, I don't know if you can see it, is blue and green. It says CReDo at cp.catapult.org.uk. And you can contact the DAFNI info at dafni.ac.uk as well. And if you have my email address, you're welcome to contact me as well. And I can always, in fact, several people who work in DAFNI with an interest in CReDo have contacted me, and I have brought them in touch with the right people from CPC, and some of those discussions are happening as well.
Okay, Jens, we've had one question come in. Can CReDo be applied to other industries?
So CReDo was designed for infrastructure operators, and currently we have water, telecommunications, and electricity distribution operators, whatever they're called. So yes, you can bring other industries in as long as you look at infrastructure and cascade effects across those infrastructures. So there are all kinds of things you might want to look at, like whether there's a hospital in a region, and you want to look at, for hospitals in particular, you want to not lose the power. You want to probably have telecommunications and stuff, and water. So you could look at parts of the region that you need to supply with these from those infrastructures, and try and model those in particular. You can look at other infrastructure. I'm trying to think what other parts of the infrastructure you might have to look at. Transport was the one we talked about, that you could try and bring in as well. So yes, you can very much apply that to other industries. Within CReDo, we are reaching out to other water companies and electricity distribution companies, and have had some discussions with them to express their to get them to express any interest they have, and also get them to share data. So typically for a trusted research infrastructure in general, getting to the stage where people are willing to share data with the platform as a trusted third party is quite challenging. And in CReDo, we have the flexibility to be able to adapt. We can introduce, so compared to phase one, we have strengthened security quite a lot as we went on throughout, and just tightened knots and bolts and things. So as a new operator of a completely different industry, or if you're a new water company or a new electricity company, if you come in and say, should I share data with CReDo, then we start that discussion based on the description of the existing security. And there may be controls that people want to have expressed a need for, that we're also looking at.
Thank you. We have a few questions waiting now. So can you say a little more about if there is any feedback loop in the elicitation process to give indications where failures have been correctly predicted?
At the moment, there isn't, except for the review button, where you can come in as a, like you log into the elicitation tool and you look at a particular model, and then you can sort of give some feedback around that. So notes and annotations and things, and go in, or even go in and edit the model. So at some point we will have versionings of models, just like we have on DAFNI. What we would really, so one thing you could look at in a real deployment scenario is where you have the asset in question communicate data back, like an aircraft engine or something, where it communicates data back to the digital twin, and then you look at that data to see. But that's just an individual asset that is communicating with us, and then you would want to aggregate some of that data across all the different substations out in the network. But then they're all in different locations and they see different parameters. So getting to that thing, really at this stage, we're relying on the information in people's heads to try and quality assure the failure models.
Thank you. Does the next stage of CReDo involve expanding and including more infrastructure partners?
Yes and yes. So with a caveat that for the Ofgem stuff, we had the Strategic Innovation Fund discovery phase that I had on my slide, and then we had the alpha phase, which finishes tomorrow. So at some point, we would like to participate in the beta phase, which is much longer, much bigger, much more ambitious, where we will take all the work we've done here and the elicitation tool that we have in the that we will enhance within the DAFNI BSRW part. And we want to try and bring that all together and deploy things for more infrastructure operators, wider regions, and at a much higher technology readiness level. So that's basically the ambition.
Okay, thank you. How much is the lead time expected if the modules are simulated for real-time scenarios?
So that's a good question, because we don't have live weather data coming into this in the model at the moment. It's based on existing data for the region, but it's based on aggregated data. So we try to do the forecasts for the different scenarios in the long term in the climate model. So that the 2-degree increase, 1.5-degree increase, 2.5-degree increase of global warming, basically. And then look at the scenarios like once in 100-year floods, once in 1,000-year floods. So it's all very much about what can happen in the climate emergency and what are the kind of scenarios we will see in that environment. So it's not so much getting real data about what the weather is now in the current modeling. It's more about looking ahead to what are the kind of scenarios we might see over the next 10 years, the next 20 years, or the next 100 years even, and how can we mitigate that on a long-term basis.
Okay, I would like to ask the source of flood data used in DAFNI or CReDo. Is the flood scenario built on current day, or have you considered the impacts of climate change?
So it is based on these different temperature scenarios. It was specifically, we used the UK CP18 data set from the CEDA archive. And there was some processing done on that by one of the project partners. And then it was fed into the flood modeling for that region, which in turn then was run by using HyPIMS. So we'll have some of the flood water, the rainwater precipitation, and any other water sources that might happen to be in the region that we look at. So again, it sort of looks at based on existing data sets like UKCP18 that's where we derive our models from. So that looks at the different temperature increases and what the model scenarios within those data sets are. And that's where we then base our models on that sort of stuff.
Okay, in the elicitation tool, are people inputting parameters directly into models, or is that tool just capturing those parameters and that information then needs to be translated into, e.g., actual Bayesian network code like you mentioned?
Yes and yes. So initially things will be done as a structural elicitation. So what are the factors that can affect a given asset? Then there will be the probabilistic elicitation, which tries to estimate the parameters of an impact on the asset based on the different parameters. Those parameters will often need to be picked up by where you put the asset out in the world. So as you say, that the asset has to be deployed in the digital twin to be useful. The failure model has to be deployed in the digital twin where the asset actually sits. And then the underlying models that are not in the elicitation tool are indeed Bayesian networks. So those effects will have to be translated from the information in the elicitation tool into mathematical models, and from there into the Bayesian networks that actually sit inside of the digital twin. So there are translation steps as we go along there, which is something we haven't worked on much yet. But again, we will look at that in BSRW and or in future phases of CReDo.
Can CReDo apply to the transport network in a big area such as in London?
In principle, yes, but we haven't got much experience with transport at the moment. And with transport, we're looking, because in the current stage of CReDo, we're looking at flooding and extreme heat. So with transport, we would look at how that might be affected by flooding. Obviously, roads can flood, and they probably don't flood very often in London. But with extreme heat, then you could get other factors that can affect, I suppose, affect transportation. So in principle, yes. Whether how far it will scale, like could it scale to London? Yes, probably. Could it scale to all of the UK? We'd need to look at how we get all the data in at the right time. So doing flood modeling for all of the UK at the same time, and then looking ahead 10 years, 20 years, 100 years. That may be a bit challenging, but we haven't really explored yet where the limits are of our existing code and infrastructure. So as we scale up, we will probably hit a limit somewhere that we'll need to work around. And one of the options for working around that is to delegate some of the heavier computations onto Jasmine, as I mentioned, and then using the Jasmine stuff to feed that into the digital twin running on DAFNI, because usually it's the weather and climate simulations that are more computationally intensive.
Thank you. Is the elicitation tool going to be made available for other projects as well as CReDo?
Yes, that's the plan. So with BSRW, so I hope we will demonstrate it at the DAFNI conference, and we will look at the existing work within the BSRW program in DAFNI, and we'll try and see how we can merge that together with the elicitation tool.
Thank you. And the last question that we've got is, how large is the workforce supporting the CReDo work across organizations?
Well, we're somewhere between 12 and 15 people of different skills, and so some people are data experts, some people are computational experts, some people are software engineers, some people are project managers, some people talk to asset owners, some people do the kind of finance modeling, sort of what are the cost impacts of mitigating things. So I think we're sort of at least 15 people, maybe even more, across the different organizations.
Thank you. That's all the questions that we have. Okay.
It's kind of one of the things that I think is interesting with DAFNI is we all get these multidisciplinary things where we have people with different backgrounds and stuff, and then we need to, when we start these activities, we often have sort of like, we kind of speak different languages because we have different backgrounds. So computational scientists, data scientists, infrastructure experts. So, but that makes it interesting that we can bring people together with different backgrounds, and some people are not experts in computing. They don't want to learn how to do computing, but we can give them that user-friendly interface via DAFNI, the visualizations to explore. And that means that we can all work together on that platform to get the best out of everyone.
Thanks, Jens. So just to wrap up, just with time, I just want to thank Jens for the great presentation. It's very insightful. I'm sure a lot of people have learned a lot about the CReDo and how DAFNI is linked to CReDo, the CReDo project. The webinar has been recorded and will be put on our website, which we'll be sharing. But yeah, thanks for everybody attending and everybody asking questions. And we look forward to seeing you at the next webinar. Thanks again, Jens.
Bye. Thank you.